All right, so we're off to number 2. A grocery store has advertised a sale on ice cream. Each carton of any flavor of ice cream costs $3.79. If Millie buys 1 carton of strawberry ice cream and 1 carton of chocolate ice cream, write an algebraic expression that represents the total cost of buying the ice cream. All right, well, the first thing you need to remember is we're talking about algebraic expressions. Algebraic expressions do not require an equal sign at the end in order for us to solve. In an algebraic expression, the variable is unknown. We know what the variable is, but we don't know what the value of that variable is. So since the variable hasn't been defined, we just need to sit there and write an expression that would represent how much it would cost for Millie to buy multiple cartons of strawberry ice cream and multiple cartons of chocolate ice cream. Now, each carton costs $3.79. So if each carton costs $3.79, then all we're doing is taking 1 carton of strawberry ice cream and then 1 carton of chocolate ice cream and just putting in the price with the variable. Because if we wanted to know how much she was going to end up paying for ice cream, we'd say, okay, so she decides to buy 5 cartons of strawberry ice cream. So she'd buy $3.79 times 5 plus $3.79 times 0 because she decides not to buy any chocolate. Okay? Now, number 3, you can look at number 3 and look at number 2. It says, based on the expression in number 2, which of the following are equivalent expressions? I'll select all that apply. Well, we know A's got to be an equivalent expression because that's exactly what we've got written in number 2. So one of these last 3 are exactly like that one. So the idea is, how would you sit there and determine this? Well, it's best like this, okay? If it's 1 carton of strawberry, 1 carton of chocolate, then she's going to pay $7.58 for ice cream. If we plug in 1 for S and C, then we only get $3.79. If we plug in 1 for C and S and D, we get $5.79. The only one that'll work is B. So those are the only ones that are possibly the correct answers. All right, so let's move on. All right, so we're moving on to number 4. Oops, too far. Number 4. So a new park was designed to contain 2 circular gardens. Garden A has a diameter of 50 meters and Garden B has a diameter of 70 meters. If the gardener wants to outline the gardens in edging, how many meters will be needed to outline the smaller garden? So we're looking at the smaller garden. That's all we're looking at. Well, the smaller garden has a diameter of 50 meters. Now, I just need to figure out which formula I'm using. Well, there's a reason why I underlined outline, because outline means the outer edge. I'm going to look at how much bricks I need to actually create the edge for the garden. So I'm just looking at the around the garden. So if I'm looking at around, I'm most likely looking for perimeter, which is circumference in circle form. So circumference is either 2 times pi times r or pi times diameter. Well, I already know the diameter. They told me the diameter of the smaller garden. Diameter of 50 meters. So all I'm going to be doing is C equals 3.14 times 50. 3.14 times 50. C equals 157 meters. And there's your answer. All these problems require you knowing how to operate the formulas. If you don't know how to operate the formulas, then you're going to end up having problems with all this. And this is going to be on your 10-ready test. Don't expect this to go away, I promise you. You will be seeing this a lot on your 10-ready test. All right, number 5. How much more edging will be needed for the larger garden than for the smaller garden? How much more edging will be needed for the larger garden than the smaller garden? Well, we already know the smaller garden was 157 meters. So now I need to find out how much circumference is for the larger garden. So that's C equals pi times diameter again, or C equals 3.14 times 70. Well, C equals 3.14 times 70. 3.14 times 70 is 219.8 meters. Now, to find out how much more edging I need, I have to subtract the smaller garden, which is 157 meters, which leaves just 62.8 meters as my answer. So it's D. All right, moving on. Number 6. A gardener wishes to put down weed block to cover the 2 gardens before the plants are planted in the ground. How much fabric will be needed to cover the area of both gardens? That tells you right there what you're looking for. It says area. So if I'm looking at area, then I know I need to use the area formula for circles, which is area equals pi r squared. Okay, so now I need to use the formula pi r squared. I need to know the area of the larger one and the area of the smaller one. Okay, well I know the diameters were 70 and 50. In order to find the radius, okay, I need to cut these numbers in half. So the radii is r equals 35 and r equals 25. Okay, that's the radii. So my formula, area equals pi r squared, is going to be 3.14 times 35 squared plus 3.14 times 25 squared. All right, so this is a straight up multiplication problem. 3.14 times 35 times 35 and 3.14 times 25 times 25. So 3.14 times 35 times equals 3,846.5 plus 3.14 times 25 times 25 gives me 1,962.5. And then you're going to add those two numbers together, and you get a beautiful number of 5,809 square meters. So that solves up through 6. So let's get ourselves down here, 7. All right, so 7 and 8 require the same information, so we need to just answer 7 first. It's asking what the radius of the semicircle is. Well, this right here is the diameter. So if I can find this length here, then I can find this diameter here. Well, I know that from here to here is 62.8 meters, or 62.8 feet, because it says a play court on the school playground is shaped like a square joined by a semicircle. The perimeter around the entire play court is 182.8, but 62.8 of that total perimeter comes from the semicircle. So if I want to know the perimeter of the semicircle plus the perimeter of the square, I can find. So this actually turns into a subtraction problem. I need to take the 182.8 and subtract 62.8, and you find out that this area right here is this perimeter is 120 feet. Now that's 3 sides, 1, 2, 3. So if there's 3 sides and 120 feet, then I got to take 120 and divide it by 3. I get 40 feet, 40 feet, and 40 feet, which means that the diameter has got to be 40 feet. Well, if the diameter is 40 feet, then I know to find the radius, all I do is take the diameter and divide it by 2. That gives me my radius. So the diameter divided by 2, 40 divided by 2 is going to be 20, so it's A. Now, all that is necessary for us to do problem number 8, because number 8 is going to require us to find the area of this entire shape. In order for us to do that, we needed to know the radius of the semicircle. So now we know the radius of the semicircle, so now we can find the area of this shape. School wants to cover the play court with sports court flooring. Using 3.14 for pi, how many square feet of flooring does the school need to purchase to cover the play court? So we need to find the area of the semicircle plus the area of the square in order to find the total combined area. Okay, well, the area for a square is length times width, plus the area of a semicircle is pi r squared divided by 2. Well, I know the length is 40 feet for my square, so that's going to be 40 times 40, plus 3.14 times my diameter, or my radius, which was 20, so that's 20 squared, divided by 2. Well, 40 times 40 is going to be 1,600, plus 3.14 times 20 squared, which is going to be 400. 20 times 20 is 400, divided by 2. Well, 2 and 400 could both be reduced by 2, so I'm going to go ahead and do that. 1,600 plus 3.14 times 200. 400 divided by 2 gives me 200. That's where I got that. Well, 3.14 times 200 is going to give me 628. If you want to double check that, do 3.14 times 100, and then take that answer and multiply it by 2. You still get 628. So your area is 2,228 square feet. That's how much flooring they need in order to sit there and get the job done. All right, question 9. Question 9. If a measure of ABC has a measure of 1/3 of CBD, then what is the degree measure of CBD? Okay, well, I've already written this information in for you. We got 1/3 M for ABC, M is CBD. But we need to find the measurement, so we need to know how many degrees each of these angles are. Well, we were lucky. We actually were given a straight angle here. This straight angle right here. A straight angle has 180 degrees. So that means angle ABC plus CBD should equal 180 degrees. So 1/3 M plus M equals 180 degrees. Well, you're saying, Mr. Hale, how can I add these two? I don't know how to add a 1/3 M and just an M. Well, you got to understand that there is an understood 1 right here. So technically you're adding 1/3 M plus 1 M, but I'd much rather have a fraction here that I can actually work with. So it'd be 3/3. Because if you think about it, 1 does equal 2 halves, which does equal 3/3, which does equal 4/4, which equals 5/5, because they all reduce to 1. 3/3 reduces to 1. Now 1/3 M plus 3/3 M is going to be 4/3 M equals 180 degrees. Multiply both sides by the reciprocal of 4/3, and you find out M equals 135 degrees. That's the measure of angle CBD. We're missing one. Somehow part of a problem got knocked off. So let's fix this real quick. Part B states if CBD was going to be equal to 9 times 8x plus 11, then what's the value of x? Well, CBD we know equals 135 degrees. So this expression should equal 135. So we just solve for x now. Divide both sides by 9. 9 divided by 9 reduces out. Leaves me 8x plus 11 equals 135 divided by 9 is going to be 15. Now I subtract 11 from both sides. 11 minus 11 is 0, so I got 8x equals 4. Divide both sides by 8. X equals 1/2. There's your answer. This is part B for 9. Somehow 9 got knocked off when I was doing something. I don't know what happened. All right. Remember, you can always pause these videos. I'm just going through getting the answers real quick and moving on. That's the whole benefit of YouTube. We can pause. All right, so moving on to 10. The dimensions of an above-ground rectangular pool are 25 feet long and 18 feet wide and 6 feet deep. How much water is needed to fill the pool, and what is the correct formula needed? So I want to know how much water can fit in a three-dimensional object. So I'm not worried about the surface area. I'm not worried about area. I'm looking at 3 dimensions and the amount of stuff that something can hold. That right there tells me this is going to be a volume problem. Volume. So that means C and D are out. So that leaves just A and B. Well, both of those formulas, volume equals length times width times height and volume equals base times height, are correct. But if you plug it in 25 times 18 times 6, only one of these is the correct option, and it would be A. Number 11, if there are 7.48 gallons in 1 cubic foot, then how many gallons of water needed to fill the pool? So if there are 7.48 gallons in 1 cubic foot, how many gallons are in 2,700 cubic feet? You got basically a proportion. You cross multiply and solve. X times 1 is going to be X. And then you got 7.48 times 27,000. And if I remember right, it should be X equals 20,196 gallons of water. I'm going to double check that before we move on. I'd rather you have the right answer than me guessing here. 7.48 times 2,700, 20,196 gallons. Questions 10, 11, and 12 rely on each other. Remember, some of these questions may not look like they were dependent on each other. That's why you got to read everything and make sure you're doing everything right. So you had the number of cubic feet based on number 10. Why would they mention cubic feet again if they weren't going to use it? So that means you have to go back to 10 and find out your cubic feet. All right, number 11. This one here, I did expect some trip-ups, because number 11 is not the easiest problem in the world, but it still is possible to solve if you've been paying attention in class. So number 11, or I guess that was 12. I've already done 11, didn't I? Yep, so this is 12. Assume there was a hole in the pool and 3,366 gallons of water leaked from the pool. How many feet did the water drop? Okay, so we know that we lost 3,366 gallons of water. I need to know how many feet it dropped. So that means we got to work our way back to this. Volume equals length times width times height, because I need to know H. Well, I know volume is written in cubic feet, okay, because I'm looking at, that's what I've been working with in these last two problems. So volume has got to be in cubic feet. Well, I know that according to this, there are 3,366 gallons lost. For every 1 cubic foot is 7.48 gallons. So I can reverse this. Take 3,366 and divide it by 748. I can find out how many cubic feet were lost. So 3,366 divided by 7.48 gives me 450. So we lost 450 cubic feet of water. Now, I've got cubic feet. This right here is my volume. So I've got 450 cubic feet equals 25 times 18 times an unknown height. I do not know H. So that means I have to solve for H. Okay? So all we're going to do is we're going to go ahead and multiply 25 times 18. We get 450 cubic feet equals 450 square feet times H. So I'm going to divide both sides by the 450 square feet. All right, the 450s reduce out, leaves me just H equals 450 divided by 450 is 1. We haven't gotten to the division of fraction or division of exponents yet, so that's just going to be 1 foot. We only lost 1 foot of water in this. So out of the 6 feet the pool is deep, we were down only to 5 feet after losing 3,366 gallons. It requires conversions, and I know that's where some of us are struggling on. Hopefully we can get ourselves caught up before 10 ready. I don't want you to go into this test unprepared. All right, so 13, our last problem. Gary is learning about tiles. His teacher passes out a small square tile and encourages the students to cut up the tiles at various angles. Gary's first cut tile looks like this. All right, we've got angle TIL, angle TIE, and angle LIE. So write an equation relating TIL and LIE. Well, TIL is here. And then angle LIE is right here. So those two angles are adjacent to each other. Well, they're also going to be complementary angles, because since they're right next to each other, they add up to equal 90. So angle TIL is 3M plus angle LIE, which is M minus 10, equals 90 degrees. All right, so now I've got my equation. So now if I take that equation and I bring it down here where it says solve for M, I can find out what M equals real quick. All right, so 3M plus M minus 10. Let's go ahead and combine. 3M plus M is going to give me 4M minus 10 equals 90. All right, so we add 10 to both sides. We get 4M equals 100. Divide each side by 4. We find out M has to equal 25 degrees. So remember that. M has to equal 25 degrees. So let's go ahead and find out what each of these angles measures. All right. So we want to know the measure of angle TIL and angle LIE. Well, TIL was 3M, and angle LIE was M minus 10. Well, we know M equals 25, so this is just to plug in and solve. 3 times 25, and 25 minus 10. 3 times 25 is going to be 75 degrees. 25 minus 10 is 15 degrees. If we did everything right, these two should add up to equal 90. 75 plus 15. 5 plus 5 is 10, carry the 1. 7 plus 1 is 8, plus 1 is going to be 9. It does equal 90 degrees, so both answers check. And you're done.